So in this video we'll discuss about complete material balance around the side stream stripper. Earlier in the previous class we have discussed about how to carry out the calculations and basic material balance to find out the ranges and yield of all these streams. So this is about the side stream. So in this side stream stripper material balance, the important thing that we need to know is what is the meaning of complete material balance. So in the complete material balance we have to find out two basic things. One is for basically barrels per hour, and barrels per hour means volume basis flow rate, and the second thing that we need to find out is the mass flow rate in terms of pounds per hour. So these two are the important flow rates for each and every streams that we need to calculate, and this is basically the complete material balance of any given system. So how to achieve these flow rate calculations? For that thing, first what we need range. With the help of range of any stream we can find out yield, we can find out mid volume percent and other parameters. And then the next thing that we need is API, and if we know the API, although the API is related with the mid volume percent, so we can find out the specific gravity. And the next thing, actual flow rate in BPSD, that is normally given. So if you know these values, you can find the barrels per hour, and also you can find the pounds per hour, means volume flow rate and mass flow rate. So you have to keep in mind that you have to find out anyhow the range of every stream of hydrocarbons, then their API, then the actual flow rates. So obviously few parameters are given always for finding out the other parameters. So let us take example of heavy naphtha stripper material balance. So earlier we did these calculations for the stripper. We have calculated everything, all these values. We have find out the flow rate, yields, we have find out the initial range, final range. So we need to find out the basically overall material balance or complete material balance. So what we do, so yield is given in the volume percent of the whole crude. That yield is important because it is a volume percent. We need to find out the flow rates of every streams. So for the whole crude flow rate, that flow rate is given 100,000 bpsd, that is for the feed, that is the crude oil that is entering into the column. So with the help of this reference value, that is 100,000 bpsd, this yield is helpful because this yield is the percentage of this total flow rate, that is 100,000 bpsd. So to find out the actual flow rate of any stream, we have to find out simply by using this equation, that is the yield multiplied by the feed flow rate divided by the 100. So in this way we can find out the actual flow rate in terms of BPSD. So let us take calculations for the F in the heavy naphtha stream, for D and for W. All these three streams are calculated with the help of the yield. Now the next is, from the flow rate and the range we can develop the following table. So this is basically the table that is required, where we have to find out flow rate in terms of pounds per hour and flow rate in terms of barrels per hour. These two are our objectives. So actual flow rates are given. So actual flow rates, you just simply divide 24, these value by 24, and you will get per hour, barrels per hour. You know the mid volume percent because the range are given. We can find out the API with the help of the graph, and if you know the API, we can find out the specific gravity using the formula. And then we have also know there is a relationship of specific gravity and barrels per hour with the pounds per hour. You can convert this one. So this is the way how you can convert every stream, except there is one thing that is missing here for the flow rate, that is a steam. Because since the steam is not a hydrocarbon, so our calculations is not based on the methods that we have described in this one, but we have to think about the concept of steam. Steam is always mentioned in terms of flow rate. For example, in our case the steam is given in 10 pounds of steam per barrel of stripped product. In our case, a stripped product, that is the distillate, liquid distillate. D is the stripped product. So what it means that for a 1 pound of stripped product, for one barrel of stripped product, we need 10 pounds of steam. How many barrels of D is produced? This is a 500 barrels per hour is the production rate of D, that is the stripped product. So for 1 barrel it is 10, so for 500 barrels it is 5000. So 5000 pounds of the steam is required per hour for this given stripper. So this is basically the overall material balance, where we have calculated each and every streams including the steam also. So you have to do all these activities, you have to fill it up, other one also, because the ranges are given and I have told you that the feed flow rate is given. You have to find out these values. So this is a task that you have to complete and submit it. Okay, thank you.